Isomers, for those who are here, can you please help the ladies who just walked in to tell us what isomers is? Yeah.
A mer is a unit and an isomer is an equal molecular formula.
Okay, so the mer is a unit, okay? So I can have a monomer and I can have a polymer. The monomer is the basic unit of something and the polymer is the many parts of the basic units. So I can have a monomer, which is 1, a dimer, which is 2, a trimer, which is 3. And it's basically building up of something. Does that make sense? Iso means equal. Equal or the same. In terms of what we're learning about, the isomer that we're talking about is something that has the same molecular formula but different structural formula. Okay? Same molecular formula, different structural formula. Okay? So we gave the example of pentane. Jury, pentane has what molecular formula? Pent means 5. So I have C5. And H would be what, considering it's an alkane? 12. Okay, so pentane is C5H12. So we know how to draw a chain, which is the regular pentane, which is 5 carbons in a row. Okay, so Saba, how would I draw the pentane generally?
5 carbons.
Yeah?
12 hydrogen.
Good. So here, how many hydrogens? 3. And then here? And then here? And then here? And then here? 3. Whoops. Okay, so I can start to write things like this. Okay? Having 3 hydrogens there rather than doing them all in bonds. So this is the next step that I'm going to be teaching you. Okay, so it's like a condensed structure. Okay, so this is the chain. I can still use the molecular formula and get a different structural formula by making branches. And the easiest way to make branches, okay, so I had 5, drop it to 4 in a row and make a side chain. Okay? So if I wanted to have 4 in a row, okay, let's start off with 3 in a row. Let's start with smaller one. Okay? 1, 2, 3. Where are my other carbons going to be? At the end or in the middle? In the middle, to make it different, because if I put them in the end, it's going to look like this again. Okay? So then I will put a carbon here and a carbon here. Right? So Badriya, how many hydrogens to this carbon? 3. So I can write H3C. And what about here? 3. And then here? And then here? Okay. Does this look the same as this? So this is this part. It has a different structural formula, but let's prove that it still has the same molecular formula. Okay? So Saba, how many carbons do you see here? C5. Jury, how many hydrogens do you see? 12. Am I still with the same molecular formula? So the molecular formula is the same, but the structural formula is different, which means the name is going to be different. Okay? So, Saba, what would be the name of this, do you think? What's my longest chain? Propane. So this is my longest chain. I can even do it down, it doesn't matter. So that's my ending, is propane. Jury, at which position do you see the side chain? The second. How many of them do you see? 2. So the way that we represent that is we start off with the first one, which is 2, and then I put a comma. The comma means I have another position, okay? Either in the same location or in a different position. So I see the first one is at 2, and the second one is also at 2. So I write 2, comma 2, dash. How many of them do you see? 2. And what's the prefix for 2? Prefix for 2 is di. And what are they? Methyl. Okay, propane. So these 2 represent the location of the side chain. Okay? The di tells me how many of them. I actually have 2 methyls. Okay, they don't always have to be the same one. One of them could be a methyl, the other one could be an ethyl. Or it could be a chlorine, or it could be an oxygen, or something else. All right? Methyl is the functional group, or the substituent I've added, and this is my longest chain. Okay? So do we understand the definition of an isomer? So an isomer would have the same molecular formula, but different structural formula. This would mean that their reactivity is going to be different. Okay, now I was asking if you can come up with a third isomer. So this is isomer 1, this is isomer 2. What's the third one?
You put 4 carbons for the longest chain, and then for the side chain, just 1 carbon.
Where?
I put it at the second.
Excellent. It doesn't matter which carbon in the middle you have because you're still going to number the same way. It's always going to be in position 2. Okay? So this is going to be CH3, this is going to be a hydrogen, this is going to be a hydrogen, and another CH3. Does this still have the same molecular formula?
Yes.
Yes. Okay, I still have 5 carbons, and the number of hydrogens is still going to be 12. So in terms of pentane, I have 3 isomers, and this is an exam question. It will ask you how many isomers does pentane have. They might give you the name, and they might give you a formula. The molecular formula, and then you have to draw the 3. So the longer the carbon chain, the more isomers that you can have. Okay? So what I want you to do right now, just in the next few minutes, I want you to try hexane.
Hexane is 6.
Yes.